In the first episode of this lesson, Kate and Christopher discovered a pattern that multiplying both distance and time values for the blue car by 2 resulted in values for the red car that made the two cars go the same speed. They noticed the pattern, but did not explain why the pattern resulted in the two cars going the same speed. In this episode, Kate and Christopher will explain why the red car, which travels 20 miles in 8 minutes, goes at the same speed as the blue car when it travels 10 miles in 4 minutes. They create a diagram to use in their explanation.
I want you to talk together and think about drawing a diagram that shows why traveling 10 miles in 4 minutes is the same speed as a journey of 20 miles.
What do you mean by a diagram? Like a chart?
A picture.
Oh, so yeah, 2 people.
Peeps.
And this guy has to walk here. This guy has to walk here. And by the time this guy goes here, this guy is here. This guy will also be here.
Oh, okay.
But he will have to keep on going still. This person here has to go a longer distance. This person has to walk farther, okay?
Yeah.
This person doesn't have to walk as far, so it won't take them as long as it will take the person that has to walk 20 whole miles.
Kate made a good start with her diagram. She showed 2 different journeys where one journey is longer than the other. The diagram also shows that the 2 travelers completed the first part of their journey together. Kate's diagram shows that after traveling the first part of the journey together, the person with the longer journey has to keep on going. But the diagram does not yet explain why the 2 travelers are moving at the same speed during their journeys. So, Kate starts over and draws a new diagram.
Yeah, I think she's good.
20, yeah. Okay. So this is at 4:20. 10. So if they're walking to the same place, they both arrive here, same time, 4 minutes. But this one decided to keep on going, so she didn't want to stop there. So and these people are equivalent to each other, so we decided to go another 10 miles. So this is 20. And it takes her, since it takes her 4 minutes to get there. Again.
If they went at 30 miles in 4 minutes,
you have to add another 4 to make it. I think we swapped this up. Wait, we swapped the bottom numbers up.
That's right.
oopsie doopsie daisy, switch the button.
You have to add 4 to 8 to make it
12.
That's why. Yeah.
If it's gonna be 30, then 30 would be 10 times 3.
It takes another 4 minutes
So you'd have
to
to
get
do
10 miles. You just have to add 4 every 10 miles this person.
Every 10 miles is 4,
You can
and
make it
every
pretty
5
bad.
miles is 2.
Kate and Christopher did it. They made a diagram that helps explain why the two people are traveling at the same speed. As Kate said, both people start by traveling 10 miles in 4 minutes. Because they are traveling the same amount of distance, 10 miles, in the same amount of time, 4 minutes, the journeys are identical and the people are traveling at the same speed. The traveler on the bottom has finished his journey, but, as Kate said, the top traveler wants to keep going. Kate's diagram shows that the top traveler repeats the same journey of 10 miles in 4 minutes. The traveler has completed the same journey of 10 miles in 4 minutes twice. Altogether, she traveled 20 miles in 8 minutes. Because the top traveler just repeated the 10 miles in 4-minute journey and didn't speed up or slow down, she went the same speed as the bottom traveler. Then, Kate and Christopher extended their diagram. The top traveler went another 10 miles in 4 minutes. Their diagram shows that altogether, the top traveler went 30 miles in 12 minutes. Because the top traveler's journey is made up of 3 identical copies of the bottom traveler's journey of 10 miles in 4 minutes, the two travelers went at the same speed. As Christopher noticed, every 10 miles is 4 minutes. The process of continuing to repeat identical journeys of 10 miles in 4 minutes without speeding up or slowing down helps explain the pattern that Kate and Christopher noticed in episode 1. They had noticed that if they kept adding 10 miles and 4 minutes to the blue car's journey, they got a list of distance and time values that all resulted in the red car traveling at the same speed as the blue car.